How would you start this one? Put it in a 2. So this is 3x, and this is sine 5 2x. Okay, what else would you do? Product rule. Before you do the product rule, I'd like you to do something else. It is a chain rule too. It is a product rule. So I'd like you to rewrite that 5. Do you see that? Because if you don't rewrite that 5, you're going to think that the outside layer is a sine. Okay, but that outside layer is not a sine. This outside layer right here is actually a power rule. You see that? You think it's the sine on the outside. So remember, derivatives works in layers. The chain rule works in layers, and the outside layer of this problem is going to be a 5. Okay, or exponent 5. It'll be a product rule. Okay, the other thing I want to talk to you guys about is what students do wrong here is they'll go 5. Okay, they'll say, okay, the outside layer is a power rule. Then they'll go 5 times 3x is 15. 15x. Carry down the inside. Take the power down by 1. Then multiply by the derivative of the inside. And I got to tell you I did something wrong. But you got to tell me why. What did I do wrong and why? 3x. 3x has an x in it. Do you see that? And because it has an x, you can't multiply that. The power rule only works if this is a coefficient. Does that make sense? Had this been just a 3, this would work. All right. The 3x says this is its own, I guess, first or second term. So you can't just use the power rule like that. When you do the power rule, this number here must be a coefficient. So let me start all over. This is 3x. So now when I step back, can you tell me the overarching rule here, besides the power rule, the overarching rule, what is it? Product rule, okay? So this is going to be the derivative of the first times the second. And the second is just copying this. Derivative of the first, times the second, plus, okay, the derivative of the second. So now this right here is the second. So I'm going to take the derivative of this. This is going to be, don't look at the 3x anymore. I'm just doing the derivative of the second. That's going to be 5 times 1. Do you see my coefficient's 1? And that's okay to have. So 5 times 1 is 5. Carry down the inside. Take the power down by 1. Okay? When you carry down the inside, you leave him alone. Is everybody good? You leave him alone. Okay? I promise I'll let you take care of him. Now we're going to take care of him. But first, you leave your little brother alone. Okay? Now you take the derivative, and everything's multiplied together. So you're going to multiply by the derivative of sine u. What is the derivative of sine u? Cosine u times du dx. So this will be cosine 2x times 2. You guys see that? Did you guys get any money?
No.
Right, don't worry about it.
No.
Okay, so let's talk about what we did. The derivative of the first times the second plus the derivative of the second. Have I forgotten anything? Times the first. So do you see how easy it is to forget that you have to multiply by the first? Okay. Darren, can you get the step up here? Okay, so multiply by the first. So I'm going to pull this over, all of this over to the left a little bit. And then I need to remember to multiply by the first. Okay? If you have this on your paper, it makes me really happy. Okay? It makes me warm. And so it tells me you really know how to do the calculus. Okay? What you may not know how to do is algebra. Okay? But I'm really good with you knowing the calculus. I need you to know that I want you to multiply anything that's easily multipliable. So anything that's, just a monomial by itself. Does everybody see that the blue can't cross the plus sign to combine with the 3? Okay, a lot of students do that, but this plus sign here is like a barrier. Okay, so you can't cross this plus sign. Okay, so if I were grading this, this is what I'd like to see. If you wanted to move this 5 inside, that would be totally fine. But let me just clarify. If you write this, this would be wrong. Okay, I know what you're doing, but this is wrong because 2x raised to the 5th power is totally different from sine 2x raised to the 5th power. Okay, but if you did this, right, that would be the 15 in here. That would be okay. So this is okay, this is bad, and this is okay. then plus 5 times 2 times 3, that would be 30x. Then just copy everything else. Okay? Yes. Any questions about that? Okay. If you forget these parentheses here, I'm not gonna have it fit. Okay. It's just nice to have. All right. Could you do that? Okay. Let's look at this. This is something that's on your test. Actually, warm-ups are always a good thing to look at before your test. If I gave you a graph and I asked you f prime of 1, can you tell me what that answer is? Okay. What's f prime of 2? D&E. What's f prime of 3? Okay, let's look at how you got that. Do you agree that this means x equals 1? Okay, so it's saying go look at x equals 1. So here's x equals 1. Go to that graph, okay? And it says find the slope of the tangent line there. So you get closer and closer and closer until this thing looks like a line, okay? And when it looks like a line, you find the slope of that line. And that slope of that line is 1. And that's where you got the 1. At 2, when x equals 2, you need to find the derivative there, or the slope of the tangent line there. But when you look at the slope, you see one slope is like this, and one slope is like this. So it doesn't agree on what the slope is. And just like limit, if you don't have one answer, then there's no limit. So here, there's no derivative, which is not the same as having a zero derivative. So everybody good with that? If you have a zero derivative, you actually have an answer, okay? If you have a no derivative, that means it just doesn't even exist, okay? Let me ask you this. What if this right here, what if this point were like this? What if I had this, but then it went to 0 right here, okay? Can you tell me what would be the slope right there? It's still D&E. Is everybody good with that? Even though once it can be 0 over here, that any point, like any sharp turn you have, that derivative is always 0. You guys good with that? Any type of sharp turn. Okay. All right. Finally, down here, what would be the slope there? 0. And the way you did that was you found 3, and you got that dot, and you got closer and closer and closer to that dot, and you found that dot, that tangent line at that dot is going to look like that. And so because of that, the slope of any horizontal line is going to be 0. Can you do that on your test? Okay. On your test, I might also, tell you to put in order all these slopes. A negative slope, a positive slope, and a 0 slope. So please make sure you can put your slopes in order also. All right. Another thing that I asked you on your test is the equation of a tangent line. Okay. What do you write down first when I ask you the equation of a tangent line? Point and slope. So you would write down point and slope, okay? And you just need a number for every single thing here. Point means you need a number for x, you need a number for y. Slope means you need a number for the slope, okay? Do I have an x? What is it?
0.
Okay. Do I have a y? No, but I can find it. So what did you guys get for your y? 0. Do you see why it's 0? Because if you plug in 0 right there, 1 minus 1 is going to be 0. E to the 0, or anything raised to the 0. 3, x cubed minus 3 raised to 0. Anything raised to 0 is always 1. Okay, now I need to find the slope of the tangent line. What did I say? When I say derivative, you say, what do they really want here? The derivative. So now I need to find f prime of x. Okay, so remember this is f, this is d, okay, and I'll need a. F prime of x equals, this is, oh boy, you see that? Oh boy. So that's going to be the derivative of 1 is 0, carry down the minus sign. The derivative of e to the x is power rule, right? Can you do the power rule here? No. Why can't I do the power rule? Because x is in the exponent. So what is the derivative of e to the x? Or let me ask you this. Do you really even need to know? You don't really need to know. What you really need to know is f prime at 0. That's what you really need to know. And if I can't find e to the x, if I can't find this step, can I find this step if I have a calculator? Okay, so on your test, and this happens every year, on your test, there's a problem like this, it's on the calculated section of your test. And students get stuck right here, and then they spend like 15 minutes on this problem, okay? First of all, do not spend 15 minutes on any problem, okay? Just move on. But second of all, if you have your calculator, could you get f prime of 0? Yes, so go to your calculator, please. Okay, what you would do is, you do a F8, okay? Do a ddx right there. Put the function right there. So it's 1 minus e, so that's second ln to the x. Okay, and then where it says x, you need to put a number. Your calculator can't find, it can't find f prime of x, but it can certainly find f prime of 0. So put 0 right there, press enter, and this is negative 1.000. All right, guys, if you have I always want 3 decimal places, okay? But if the decimal places are all zeros, you can just put, like, you could disregard it, okay? If it's like, you know what I'm saying? If the zeros, you don't have to put it there, okay? It needs to be accurate to the third decimal place. All right, so this is negative 1, okay? So I've got a number, I'm pretty happy. So then you go to the point slope formula, okay? And you say y minus y is equal to the slope times x minus x, all right? And that is a great answer. You can leave it just like this, okay? If you simplify it, the answer would be y equals negative x. Okay? If you leave it like this, I will counter it correct, okay? It really, not because I'm happy with that answer, but really because I'm testing you on your calculus, okay? And if you get that far, I'm like, you know your calculus, okay? I will make a note and wonder about you. Okay, I was saying, well, I wonder if Grayson knows that x minus 0 is x. I wonder if he knows, but I won't mark it wrong. Okay, and then, but this would be probably if this were a multiple choice, this would be the answer. Okay, all right, you can do 3 minutes hand on our test. It's not very hard, especially if you review. So let's go to your homework from last night. Can you guys just tell me what questions you need help with? All the answers have been posted. So if you guys can just tell me, I'm just going to do a bunch of random problems up here preparing for your quiz. Okay? So throw out a problem. Okay, we're going to look at 49, guys. So 49 says I want the derivative of cotangent 2x cubed raised to the third power. Okay, is everybody good that you have to rewrite this problem? Okay. Did anybody not rewrite this problem? Okay. If you're raising your hand, get out of it. Okay. You have to rewrite this problem. Otherwise, you're going to think that the outside layer is a cotangent layer, but that's not true. The outside layer is a power rule. Okay. So so this is going to be the outside layer. Okay. So you see it's a power rule here. So 3 times 1 is 3. Okay. Carry down the inside. Take the power down by 1. When you carry down the inside, you need to leave him alone. Okay, do not take the derivative and put it right there. Okay, leave him alone. Now, after you leave him alone, multiply by the derivative of the inside. So the derivative, and you've memorized this, the derivative of cotangent u is negative cosecant squared u times du dx. So here, my u is 2x cubed. So this will be 2x cubed, this will be 2x cubed, and the derivative of 2x cubed is 6x squared. So I'm going to copy this answer down here. This will be negative cosecant squared 2x cubed times 6x squared. Okay? Now this is what students do wrong. They don't know what this negative means. Okay? This is not a subtraction. In chain rule, this is 3 times, leave the inside alone, take the power down by 1, then you multiply by the derivative of the inside. This is a multiplication. This is not a take away 1 or take away cosecant squared. This is a multiply by negative 1. You see that? And that's where students have trouble. Not a take away, it's a multiply. So there's several multiplies here that you could do. You can multiply by the 6x squared, the 3, the negative 1. Okay, so what I would want you to have, if you wanted full credit on this, actually, if you go here and you're not sure where to go, you can just stop. I'll just take off 1 point if you don't go further. Okay, but if you go further, you should have negative 18x squared, and then you copy everything else. Cosecant squared 2x cubed. Whatever you do, do not multiply by 2x cubed with all of these highlighted areas. Okay, the 2x cubed belongs to this cosecant family. Maybe not the negative here, but it belongs to the cosecant squared family. And please don't take him from his family. That's not nice. Okay? There was something, okay, the other thing I want to mention, which I might have mentioned before. But whatever you do, please don't write this. This is wrong. This is squaring just a 2x cubed. This means you square the whole cotangent, okay? So please make sure you understand that that is wrong. If you write that, I'll count it wrong. You can, though, if you want to move that 2 in. If you move that 2 in, then that would be correct. Okay, so this is correct, and this is also correct. All right. What other problems do you need help with? Yeah.
Parentheses, like to the left of contingent, and then to the right of like that x cubed and one right, and then you put like this.
Yes.
Oh wait, no, not that one on the boil.
Yes, and then put the parentheses where you can do the board and do it. I'm not sure where.
I don't, I don't-
Or just tell me where. Like,
it's like, I don't.
why don't you come point? I don't know where you're talking. Like these. This is correct. This is correct. If you put the bracket here, that would be correct. Here, I'll give you a pen. Just write on it. Use your.
You would go like that and then square that without having like that and that.
Yeah, you can totally do that. Okay, that's fine. Wow, it's so many iterations. Okay, what other problems do you need help with? Don't be shy, guys. Okay, number 50. Okay, number 50 is y equals secant, and I'm going to rewrite this. Secant 2x raised to the third power over x squared. Okay, you have to rewrite it. If you don't rewrite it, you're going to think the outside of this is a secant problem, but it's not. The outside is a power rule. All right. I'm going to go with quotient rule. You could actually move this up and do product rule. Do you guys see that? But I'm going to do quotient rule because I think most students would go with quotient rule on this. All right. So this would be the first. Okay, and this will be the second. So we're going to say the derivative of the first. This first, do you see, is a power rule. So it's going to be 3 times 1, which is 3. Leave the inside alone. Take the power down by 1. When I say leave the inside alone, I mean leave him alone, guys. Okay? Then you multiply by the derivative of secant u. The derivative of secant u, do you remember, is secant u times tangent u times what? Du dx, so times the derivative of u. So the derivative of first times the second, okay, so multiply by x squared, plus, not plus, minus the derivative of the second times the first, so the first is just copying this thing right here. Okay, don't forget, I saw this on the quiz too. A lot of people did quotient rule, but they forgot that the quotient rule has what? Like a denominator, right? So all over the bottom square. So please, you've done so much work, please don't forget the easy part, which is dividing by the denominator squared, okay? If you leave an answer like this, you probably won't get full credit, but I'd be pretty happy. I'd feel really good about what you know. I want you to combine those parts. Remember, do not cross this negative sign, okay? So this negative sign is a barrier right here. All right, so the 2x is pretty much by itself here. You can't take that and combine it. Only the yellow. Is everybody? Yellow is all you can combine. Down here, you could leave it x squared if you're not sure how to do this. But if you're sure how to do it, then it's x squared 4. Okay. All right. What other questions do you have? All right. Then let's go on to today. So can you guys look at your notes for today? Okay, we're going to do this problem together. A lot of this is review. When you do your homework on this packet, please only do 3, 4, and 5. Number 3, 4, and 5. Okay. For this packet right here, the one with all the words on it. The one that says 1.2-7. The one that says 1.2-7b, you're going to do the front and the back. Okay, so the landscape one, you're going to do the front and the back. But the other one, you're just going to do 3, 4, and 5. Let's do the example problem together, though. They give you a table. They tell you W is the amount of water in some sort of tank. Okay. T is the time. All right. Use the data to find W8. So is everybody good that W8 is 221? Good with that? And then it says use this unit to explain the meaning of your answer. Okay. And you guys knew how to do this before you came into calculus. So then you say at time equals 8, but you got to put the unit. Okay, so you can't just say 8. You have to put hours. Okay, W, W is the amount of water. So you'll say the amount of water. Okay, you can say of water, but I'm just trying to use like the fewest words I can. The amount of water is equal to 221, and you have to say the units. So how much units? What is the units here? Gallons. Okay. Usually on AP test, this is just 1 point. And the sad thing is, if you just missed one thing, like if you didn't put hours here, suddenly it's you don't even get that 1 point. Okay, so just please make sure you have your number, your unit, your number, your unit for the X and the Y. All right, next question. What is W negative 1 to 57? Is this a derivative? No. Okay, so can you tell me what this answer is looking at your table? Okay, is everybody good with that? What is this negative 1 if it's not a derivative? It's the inverse. So inverse means swap the X and the Y. So if this is time and this is W or amount, so now this is the amount and this is time. Okay, just swap the W and the T. So this is saying at or at doesn't make sense. I'll say when the amount of water equals 257. You put your units. What units would that be? Gallons. The time is equal to 12. And then what units would that be? Hours. You see how easy that is, okay? And I use the fewest number of words I can because I'm an immigrant. You guys can do whatever you want, but just make sure it makes sense, okay? Like, yeah, just make sure it makes sense. Let's go look at C. Okay, C says, find an approximation for W prime of 15. So if you're given a table, how do you find the derivative? Yeah, you do the quotient thing. Remember that? The average rate of change. Go find 15. Remember, this is really the X value here. So this is the time. Go find 15. And do you see you do the symmetric quotient? Just look to the left and right. You can actually like look as far left and as far right as you want to. Okay, but to me, it's easiest just to look at the left and the right of 15. So I'm going to grab this one and this one. So this is going to be W prime of 15 is approximately equal. It's not equal, but it's approximately equal to a slope. So 294 minus 257 over 16 minus 12. Okay. Whatever you do here, please make sure you have a y minus y over x minus x. Okay. Do not. You should never have a y over x. Is everybody good with that? There's never a time when the derivative is equal to y over x. Okay. You need to have 2 y's and 2 x's. Okay. Does it want me to show units? Yes. If this is a free response, which it will be on your test, okay, you can stop right there. Is everybody good with that? If you want to go on and tell me what this is, anybody go on and tell me what? Okay. If you want to go on, great. But if you go on and give me the wrong answer, you get a -1. Okay. So just be careful. But some of you guys like giving the final answer. I like doing that too, so I get it. Just make sure you give me the right answer. What would the slope be? What would the units be here? Gallons per hour. So it's the y over the x. So for sure, the units is y over x, okay? But the number here is never y over x. Everybody does that. The number is always y minus y over x minus x. You never would give me a number with y over x. Okay, let's look at E. It says, must there be a time when the tank has 265 gallons of water? What theory are they testing on this? IVT, right? IVT. Is there a time when the tank is 265 gallons of water? So look at this, guys. Where would 265 be? Right here? Anywhere else? No, just that one. Okay, so do you see? Yes, there is a time by IVT, because what has to be true, though? What has to be true for you to use IVT? W must be continuous. So right here, I'm going to write it up here. 1, you're going to write the function is continuous, and our function here is WT. So WT is continuous on that interval, whatever interval they tell you. Okay, it is continuous. guys, even if you don't know if it's continuous or not, just write it's continuous. You can't use IDT anyway if it's not continuous, okay? So just write it. Unless for sure it's like a trick question. They're trying to see if you know if it's continuous. Okay, so first is continuous. Then you write your W at 4. Oh, wait. No, sorry. It's 0 to 24. I'm looking at the wrong thing. It's 0 to 24. So then you write your W at, where, did I just skip a problem? Where am I? I thought I was doing IDT. What problem am I on? Oh, I'm on E. Okay, sorry. I'm on E. Okay, did I skip D then? Oh, okay. Okay. I thought this was just the problem. Okay, let's do that here. So WT is continuous on the interval that they tell you. And then 2, you want W at 0 and W at 24. Okay, so go find that on the table. 0, what are we at? 150? No. Actually, I don't want W at 24, sorry. I want W at, is it 16? And W at 12. Do you see why I'm grabbing those? Because I want 265. So 265 is only, that's the only way I can prove that this is true. So this is 257, and this is 294. I need a number where 265 is between those numbers. Okay? Then I'm going to state that 265 is actually between those numbers. So 265 is between 260, 257, and 294. Okay. Oh, I actually could have used 0 and 24 also. You guys see, I could have used 0 and 24 because that would have worked too, because 265 is between 0 and 24. Okay. And then finally, number 3, I'll say, yeah, there is a time when WT is equal to 265 on that interval on 0 to 24. So I'd say, if they ask you how many times, here, answer the question. Must there be time? Yes. Just make sure you answer the question. Okay. The answer is yes. Okay, there is a time. A lot of times they won't ask it. A lot of times they'll say, how many times? Okay, if they how many times, here you would say at least 1 time. All right, let's look at D, because I skipped that one. This is your new formula, average rate of change. Okay, on your formula quiz, I'll ask you, give me the average rate of change of f of x, and you will tell me that that's f of b minus f of a over b minus a. That's the formula you'll memorize. But here, they don't want the average rate of change of f. What do they want the average rate of change of w? So all your f's, okay, the name of your function changes. So now this is w. You see how that works? And then you have to get the x values that they want you to go between. And so do you see here they gave you the x values. They'll always give you the x values. So this is going to be a, and this is going to be b. And you're going to put that right into your a and b. So this will be w at 20 minus w at 4 over 20 minus 4. You guys good with that? Okay? If you write just this and you write nothing else, you will get partial credit. Okay? Because this says you know your formula and you know what numbers to plug into your formula. Okay? That's what you're telling me. And so I'll tell you that. Great job. Okay? But then you also need to find these numbers. So W of 20 is 327. I'm writing it backwards because I don't have any room. So 327. W at 4 is 184. And then 20 minus 4. You could write 16 here, or you could write 20 minus 4. It doesn't matter. Is everybody good? That is your answer. Okay, if you want to go further, more power to you. Do I need the units on this one? Do they ask for units? No. If they don't ask you for units, you don't need to put the units. If you put the units and they're right, great. If you put the units and they're wrong, then you get a -1. Okay, so it's better to just not even put the units if they don't ask. Okay, but if you needed the units here, what would it have been? What's the unit for W? Balance. And then what's the unit for time down here? Okay, so it's still y over x. Is everybody good with that? Okay. And again, you would never do y over x for the numbers. Okay, the numbers would always be y minus y over x minus x. But the units is y over x. Okay. All right, let's look at letter F. Letter F says a model for the amount of water in the tanks given by A. So they're giving you a formula for for the tank, this AT, the amount of water in the tank. And AT is measured in gallons and T is in hours. Find A prime of 15. I need you to understand that this is saying, don't look at the table anymore. I don't know if you understand it. They're saying that table is a bunch of random values for the amount of water. But now I'm giving you a formula for the amount of water. Use this instead. That's what they're saying. Even though this is part of the question that's in the table, you don't use the table for this. They're just saying find A prime of 15, okay? And if you didn't have a calculator, you could do this. This is your F. Your derivative would be A prime of T is equal to, and then this is a coefficient, so you'd say 1 over 225 times, and you would just take it out and take the derivative of this. And the derivative of this is negative 3t squared plus 60t plus 1800. So everybody go with that. And if I wanted A prime of 15, so remember FDA, this would be equal to 1 over 225 times negative 3, 15 squared plus 60 times 15 plus 1800. Kind of messy, but you could figure that out. If this is a free response, this is kind of nice. You see, you could stop right there. So I got all my numbers in. Okay, I can stop right there. Just make sure you got it right. If you had a calculator, though, so let's look at the calculator. If you had a calculator, what you could do, and I'm going to go ahead and show you how to do this. You could store your A1, because it's such a complicated formula, you could store your formula A into Y1. So let me show you how to do that, and you can use Math 8 and pull the Y1. So please go into your calculator, hit your Y equals button, okay? Then type this in. You're going to like this. Type this in. So this is 1 divided by 225. Okay. I know I can use the ND thing, but I'm just not. And I'm going to multiply this, so I'll do a times this whole thing right here. Instead of T, though, I'm going to use X, because there's an X button right here on my calculator. There's not really an easy way to do the T, so I'm going to use X there. So this is negative X cubed. I know some of you guys like the T, but really, if you just don't tell your calculator, it won't know. Just don't tell your calculator, okay? If you're using X's instead of T. So this is squared plus 1800 X plus 3. Okay. So once you put that into a calculator, I like to arrow down and be like, okay, now it's kind of clear. And that's stored in Y1. Everybody's good, that's Y1. So go to second quit, and that gives you your home screen. So Y1's already stored. Now you have your home screen. Now type Math 8, okay? This would still be an X. You're taking the derivative with respect to X, so put X there. Right here, instead of typing that whole function, you could pull back your Y1. And the way to do that is hit alpha trace, and then select whatever function you want. And I want the Y1. So I'll just hit enter, and it puts the Y1 right there. Okay? So that was alpha trace, guys, for the Y1. Then arrow over to the X and put in the number you want. I want to put X equals 15, okay? And hit enter, and my answer is 9. Okay, and if you did it by hand, I think your answer should be 9 also. Because it's just 9. Let's see how to do that. So your calculator is kind of nice. It's measured, fine. Okay, and that's the answer. It doesn't tell me to find units, so I'm not going to find units. Finally, the last problem says, find the average rate of change of AT over the period. So what is average rate of change? I would write the formula. They want the average rate of change of AT. So remember, average rate of change is F of B minus F of A over B minus A. It's just going to memorize that. Average rate of change is a slope. It's what you knew the slope was before you came to this class, and I confused you. Okay? So instead of F, though, my function is called what? A. So I'm just going to replace all the F's with A. And what is my little a and little b now? The 4 and 20. Okay, so I'm going to replace that. So now I have a at 20 minus a at 4 over 20 minus 4. So I'm going to plug a of 20 and a of 4 in. Now this is kind of nice. Let me show you how to do this with your calculator. If you want a of 20, wasn't a named y1? Okay, so this is really just saying y1 of 20 minus y1 of 4. And you can enter it in just like that on your calculator. So I can do y1, so do alpha trace and pull your y1, okay? Then open your parentheses are right here. Open your parentheses and put 20 and close your parentheses. That's y1 of 20. Okay, if you wanted the value for that, just hit enter, and that's what the value is. Okay, but if you wanted to just say y1 of 20 minus y1 of 4, so let me pull back the y1 of 20. If I wanted y1 of 20 minus, I could just do minus y1 of 4. So I could do alpha trace, choose your y1 again, open your parentheses, put in 4, close your parentheses. Do you see I'm doing a20 minus a4? Then press enter, and I'll have the numerator. And then you can just divide by 16, and then I'll have the whole number, which is 8.995. Remember, you can truncate or you can round correctly. You got to go 3 decimal places.